In this question, we have to find out the acceleration of block A and block B. There are two fixed pulleys and one pulley is movable pulley. Okay. So let's say the tension over here is T. Here also the tension will be T. Here also the tension will be T. And here also the tension will be T. Here also the tension is T. All because this is entirely one string. Okay. That's why the tension is same. Let's say the tension here is T dash, right? Now let's find out what is T dash. Now we have assuming that this pulley is a massless pulley. So if I draw the free body diagram of this pulley, I will get two tensions upwards, that is T plus T, and another tension downwards as T dash. Now if I assume this pulley is accelerating downwards with a certain acceleration A, then I have this equation T dash minus 2T is equal to MA. This is mass of pulley. But the pulley is assumed to be massless, so the mass MP will be 0. That means T dash minus 2T is equal to 0. So from here, T dash value will become 2T. This is the value of T dash. So this tension T dash is nothing but 2T. So this I can directly write here 2T. Okay, so let's relate the accelerations now. What will be the acceleration of this particular block B compared to this acceleration of the block A? Let me redraw this situation over here. Okay, if I see this pulley over here, the movable pulley, I can redraw it like this. One end is going over another fixed pulley and it is fixed over here. Okay, and another one is going on another pulley and this is attached to one block. Now if I say this pulley has gone down by certain amount x, right, it has gone down by certain amount x, then this string is being relaxed by 2x amount, right? This pulley has gone down by x means there should be extra x string here and extra x string here. Where does it come from? It comes from only this part. Because this part is not movable, this is fixed, so this part only can move, and to compensate for this string, this part has to move by 2x amount. That means if the acceleration of the pulley is A, the acceleration of this block will be 2A. Why I am saying that? Because if the displacement of this pulley is x, the displacement of the block is 2x, the velocity is v, then the velocity of the block will be 2v. If I differentiate again, I will get acceleration relationship. So acceleration of this pulley will be downwards A, and thus for this block B also the acceleration will be same, that is A. And this block A will move towards right by 2A amount. Okay, there is yet another method of doing this, that is called virtual work method. If you don't know about virtual work method, you can see my previous video on this, where I have given the title how to relate the accelerations between the blocks and the pulleys. Okay, so let me do it over here quickly. In virtual work method, what happens is that we say in virtual work method, we say that total work done by internal forces is 0. That is summation over I, Ti xi is equal to 0, where Ti is the tension of the ith object multiplied by the displacement of that ith object. So here for B block, the tension is 2T. So I will write 2T times xb. This is the displacement of xb. And here I will write T times xa. So plus T times xa. So the addition of this must be 0. If I divide both the sides by T, I will get 2xb plus xa is equal to 0. So xa is equal to minus 2 times xb. If I differentiate both the sides twice, I will get acceleration of A to be minus 2 times AB. So here you are getting the relationship between the acceleration of block A and block B. So from here you can see the acceleration of block A is twice that of acceleration of block B. Okay, so here what you are getting is that the relationship, right? Basically. Now, what we will do here, we will see why by the way it is negative here. Why AA is negative to that of 2AB. That means that this work is entirely opposite. See, B block is going down, right? So that means the work done is negative. Attention is upwards and displacement is downwards. So this work has to be negative, and this work has to be positive because the tension is in this direction and displacement is also in that direction. Okay, so this is in a sense negative work. We did not count that, we just wrote positive TXA. So that's why we are getting the minus sign. Okay, now let's find out the accelerations. Okay, now we got that if the acceleration of A is 2A, the acceleration of B is A. So just do this free body diagram. For B, the free body diagram will look like this. Let me use red color now. So this is B, mg force downward, mbg basically, 2t force upward. So mbg minus 2t is equal to mb times A. And for 2 kg block, that is the A block, we have E is equal to ma times 2A because the acceleration is twice that of B. Now what we will do, we will multiply both the sides by 2 and we will add these two equations. We will get mbg is equal to mb plus 4ma times A. So that will give you A to be mbg upon mb plus 4 times ma. So what is mb? Mass of block B is 5 kg and mass of block A is 2 kg. So this will be 5 into 10 divided by 5 plus 4 into 2. This will be 50 plus 4 into 2 is 8 and 8 plus 5 is 13. That means it is 50 by 3 meter per second square A, and the acceleration of the block A is twice that of this, that is 2 into 50 by 13 meter per second square.